the most part, the only one that gave y'all problems was the last one, which is what I expected, but most of y'all were able to get to the factoring part, and then we had trouble from there. So today we're going to do some problems that have to do with factoring, but I think we'll be fine. If not, we can review a little bit. But first, the bell ringer. Boat leaves the dock and sails directly north for 5 miles, and then it turns and sails 12 miles east. How far away is it from the dock? So, what would be helpful if we're not very good at just coming up with these problems in our head? What do you think would be helpful? What? Write down the numbers, but in what way might help us a little more? How about drawing a picture? Drawing a picture. So like say our boat starts here. Alright, there's the dock. If it travels directly north for 5 miles, which way is directly north? Up, down, left, or right? Up. Up. North is up, so I'm going to go up 5 miles. Which way is east? Right. So I'm going to go east 12 miles. Does that look kind of familiar? What if I draw, now this is where our boat is. So our boat. This is our dock.
Oh, that's a cute boat.
Thank you. Quite the artist. Not really.
Suck at tracing.
Alright. What distance am I looking for? I'm looking for the distance between the boat from the dock. That's this distance, right? That distance. What picture have I drawn now? What shape? Shape?
Right.
A triangle. What part of the triangle is this dotted line? What's the fancy word for that part of the triangle?
Hypotenuse.
Hypotenuse. So this is the hypotenuse. I've got one side, I need to find the hypotenuse. What's the big fancy word formula that I need to use to find this?
Wait.
Yes, Pythagorean theorem. So we'll have a squared plus b squared equals c squared. A and b are these sides, the hypotenuse is always c. So I'm going to have 5 squared plus 12 squared, and that'll equal c squared. That's what I'm looking for. What's 5 squared?
25.
25. What's 12? 12 squared. So that equals c squared. What's 25 plus 144?
169.
So we get 169 equals c squared. Then what do I do to solve for c? A little kind of what we did last week, a little bit. How do we solve for c? If c squared, what's the opposite of squaring something?
Square root it.
Square root it. So c is going to equal the square root of 169. So what's c equal? What? 13. So that will be j. Questions about this one? Alright. I failed to mention for y'all to pick up these when you came in. Here we go. Alright. In the grand scheme of things, Rational expressions aren't bad, but there's a lot of algebra to it. So, what word or words do you see in rational? What other math words do you see in rational? What?
Ratio.
Ratio. Alright, so what is a ratio? What's another word that we use a lot instead of ratio? We use this word.
3.14. Oh no. That's pi.
That's pi. We use this word
3.14.
instead of ratio a lot because it's easier and more
What is this?
common. F. Fraction. Alright, so a ratio
I'm not here today.
is another word for a fraction. So all of these problems that we're doing today
3.14.
are all fractions, right?
Sadly.
My finger quote.
So, we're simplifying these rational expressions. Now, unlike when we just have normal fractions, like one number over another number. Those simplify really easily. But now we're plugging in variables on the top and bottom, so it's going to change a little bit. The first thing we're going to do is when we simplify, we have to cancel common factors. Now some variables, they can be our answer, but if we have a common factor, we're going to cancel it. Now, this is the big part. When we cancel, if we have x plus 8 divided by x plus 6, I can't simplify this and just say, oh, I can cancel those, and then I'm left with 8 over 6, which simplifies to 4/3. I can't do that. Because what happens if I were to say, well, what if x is 2? What's on the top? What's on the top here? If say we plugged in 2 for x, what do I get? 10. What's on the bottom? 8. Does that simplify to 4 over 3? No. So that's why we can't cross out the x's and get rid of the x's. The plus or minus signs make it a little more difficult. How we would cancel is if I had x plus 8 times x plus 6 over x plus 6. Then I could cancel that. I have to cancel the entire piece to be able to cancel. Does that make sense? Alright. Here, if I have these two, if I have these two pieces, I can't cancel the x's out and just say I have 8 divided by 6, which would then simplify to 4/3. I can't do that with variables because these change. So we're not necessarily sure that this is going to be 8 and 6. So we have to have the entire chunk to be able to simplify, or to be able to cancel. So the numbers just can't be the same. The number and the variable has to be the same. Like over here, how I rewrote it. This is just saying, I can't cancel this. I can cancel these two if there's an x plus 6 on the top. I didn't magically just, these are two different examples. I didn't magically pull an x plus 6 out of here. I'm just saying the x plus 6 needs to be up here for me to cancel anything. Is that what got you? Alright, let's look at it and then maybe by looking at some examples we'll see. Alright, then, if we have a fraction, what number cannot be in the denominator? No, we can have a number bigger in the bottom. What number can we not divide by? 0. So we're going to have these things called excluded values. Alright, so we need to find, so we've got to find these before simplifying. And I'll show you why in the first example. Now, these excluded values, they're also called restrictions. So that's the word I'm going to use for them. When I'm talking about them in class, just because it's one word rather than two, no, there's no real reason. Either one of these are the same thing. So on a test, you may say excluded values or restrictions. If it asks for find the excluded values or find the restrictions, it's asking for the same thing. And so what these restrictions are, is they're numbers that if we were to plug them into our function, our expression, then the denominator would go to 0, and that's what we don't want. So let's take a look at number 1. So, what we just talked about, we want to find our restrictions before we do any simplifying. So, later on we're going to factor, but do we need to factor? Can we factor anything here? We can just simplify. So, I'm going to go ahead and find my restrictions. So my restrictions, which I'm just going to put as an R. What number, if I plug what number in for C, will make this whole thing equal 0? If I plug in a number for C, what? 0. 0 is the only number. So if I plug in 1, it'd be 8b, right? If I plug in 2, it'd be 16b. So the only number that's going to, if we have C, the only number that we plug in for C to be 0 is 0. What about B? Same thing. So for any time you have one term that has one or more variables in it that is just multiplying, our restrictions are always going to be each variable cannot equal 0. So my restriction, I'm going to say C cannot equal 0 and B cannot equal 0. Alright, that's the first part of our answer. For these, you're going to have more than one box for each problem. And we'll come back to those. I'll re-explain it once we simplify. But we can simplify now, right? What can we simplify? Let's just work with the numbers first. How can I simplify 16 and 8? Can I simplify 16 and 8? Yes, no, maybe. What's 16 divided by 8? 2. Alright, so this becomes a 1, this becomes a 2. So I'm going to get 2. Now, I'm going to rewrite each of these using our rules. If I'm dividing two variables with different exponents, I'm doing what? What do I do with those exponents? Alright, 2 times C, and then the exponents are going to do what? What? Correct. Perfect. So I'm going to do C to the 2 minus 3, B to the 4 minus 1. Remember, there's a 1 there. So remember, when I'm dividing variables, or even other numbers, if the bases are the same, I subtract the exponents. That's why I can write it as C to the 2 minus 3 and B as 4 minus 1. So then this becomes 2 times C to the negative 1, B to the third. Everybody good with those two steps? We remember that a little bit? Now, another thing, another rule of exponent. I have a negative exponent here. I don't like negative exponents. How do I get rid of the negative exponent?
Put it on the bottom.
Put it on the bottom. I move it across the fraction bar. So this time I'm going to have 2 and B to the third on the top, and just C on the bottom. That's our answer. Now for these, you're going to have 2 or more boxes. Alright, you're going to have the box for our normal simplified answer. You're going to have a box or two depending on how many variables you have in your problem for your restrictions. Now look, this is why we do the restrictions first. The b's not on the bottom anymore, is it? But if we go back to our original problem, b is in the bottom. So b can still equal 0, right? That's why we do the restrictions first, so that we get the variables that may be in the bottom in our first one, but still cancel out at the very end. Any questions on that one? Or you all want to see another one? Let it sink in. Alright, for 2, same thing. I can simplify the numbers. I can use that same rule for the exponents. So how can I simplify 32 and 4? Divide both by 4, so 8 over 1, good. So I can rewrite this as 8, and then what can I do with the x's? I can say x to the what? X to the what? Wrong way, wrong way. 4. Remember, it's 8x to the 5 minus 1. That's a 1. Remember, when we divide, we subtract. So then I'm going to have y to the 2 minus 7. Alright, what did we forget to do before we started simplifying?
Restrictions.
Restrictions. We're still fine. We can still do it. We haven't really simplified yet. But again, the trick with this is I've got two variables here and there's no plus or minus with them. If there's no plus or minus with them, what's the only number they cannot equal? 0. So my restriction is going to be x cannot equal 0 and y cannot equal 0. Alright, those are the nice and easy ones. Now back to simplifying. I'm going to have 8 x to the what?
1.
Y to the 2 minus 7, guys. Negative 5. What am I doing with that negative 5? Bring it to the bottom. So I have 8x to the 4th over y to the 5th. No, these are nice. Alright, but now what happens if we throw in a plus sign in on one of the top bottom? Alright, first thing we're going to have to do is factor the denominator. Now, there's 3 different things we're going to end up factoring, or 3 different ways we're going to end up factoring. The first way is if we have 2 terms. If you have 2 terms like this, where I've got a coefficient in the first and the second one, and a variable in the first and the second one, is I'm going to pull out a common term, a common thing. So what's common in the 4 and the 4y squared and the 6y? They're both divisible by 2. So I'm going to bring down my 2y on the top. I'm not doing anything to that. So I can factor out 2. Is there anything else I can factor out of that bottom? Anything else I can factor out of the bottom? Well, how many y's are there with the 4? 2. How many y's are there with the 6?
1.
So there's at least one y in each of them, right? So I can pull out a y. Now, 4 divided by 2 is what? Y squared divided by y is y plus 3. The other y in the second one goes away. Alright? Now, this is the point where we want to find our restrictions. If we have to factor, this is the point. Because now we've done everything up to the point of actually simplifying. So our restrictions here are going to be a little different. One restriction is going to be this piece here. So now, each piece of our denominator is going to be a restriction. Whether it's the 2y or the things in the parentheses, that's what it's going to be. So I'm going to say 2y cannot equal 0, and 2y plus 3 cannot equal 0. Does everybody see where those two restrictions are coming from? Yes, no, maybe? Sure? I'm just setting each piece of my denominator equal to 0. What can y not equal in the top? What's the only way that 2y can equal 0? Is if y equals 0. So y cannot equal 0. And then what about the bottom one? We got to solve a little bit. So what's the first thing I have to do to get y by itself? What's the first thing we do to get y by itself in that bottom part here? What? Alright, we've already factored. Guys, what if this said equaled 0, what would y'all do?
You would subtract 3.
I would subtract 3. We're just solving for y. We're getting y by itself. So how would I get y over on that side by itself? Well, I got to move the other numbers to the other side. Just like we're solving equations, except the only difference is now I have a not equal to sign instead of an equal to sign. So then I'll have 2y cannot equal negative 3. Well, what's the last thing?
Divide by 2.
Divide by 2. So, in this case, y cannot equal negative 3 halves. And if we want to check that, we can plug it back into the top. Now we can simplify. What can I simplify over here? Remember, they have to look exactly the same. If they're in parentheses, the entire thing in parentheses have to be the same. So what can I simplify? I can simplify the 2y on the top and the 2y on the outside. Alright, I can't simplify that 2y on the inside because if I were to simplify that 2y on the inside, I have to have the entire parentheses of 2y plus 3. So my answer is going to be 1 over 2y plus 3. Is the factoring the part that's getting us right now? Or is this just a... I know this is a tough section. The factoring? I think once you see it more, I mean, obviously it becomes a little easier. But I think we should get the hang of it too. So let's look at 4. Alright, 4 is the same thing, except do we have to factor just one of them? We're factoring the top and bottom, right? So if I factor the top, what can I factor out of the top? Can I factor out an x? Sure. Does the 6 have an x with it? Nope, I can't factor out an x. Can I factor out a number? Yeah.
Yeah, two. Well, wait, we did the top.
Yeah, I'm doing the top.
Three.
3. I can pull out a 3. What's 3 divided by 3? 1. So I'm left with 1x. What's 6 divided by 3?
2.
Over. What can I factor out of the bottom?
2.
What's the number I'm going to pull outside of the parentheses? 5. I can divide both those numbers by 5, so I'm left with x plus 2. I can't factor anymore, can I? I can't factor anymore. So before I simplify, I've got to do what? I got to find my restrictions. The little r. Now this one's nice. I only have to do one. Now, I want to point out,
You cancel that x plus 2.
we will in a second, yep. The 5. Is there any way that 5 can equal 0? No, there's no variable attached to it. So if there's no variable attached to the number on the outside, I don't set it equal to 0. Because there's no way that 5 can ever equal 0 by itself. So the only one I'm going to say is I'm going to say x plus 2 cannot equal 0. So then what do I do to get x by itself? Subtract the 2. So I get x cannot equal negative 2. Then what can I simplify? Devin just said we could simplify it. What can I cancel out? What's the same on the top and bottom? The x plus 2, the entire thing. So all I'm left with is 3/5. You all right over there? You sure you're good?
Yeah.
I don't think so. He's struggling. He's worse than Kayla was on Friday.
Because he keeps shaking.
Wait, I was laughing.
His face is like bright red.
I was.
No, maybe it was Thursday.
It was Thursday.
Maybe it was Thursday. It's so funny. Deep breath. What? Thanking yourself?
I told a joke to myself in my head.
It's probably a good joke, maybe.
Don't even get me started.
Oh my God, please stop.
Alright. We have really 2 more examples, and I'm going to have y'all work on the last one. So, for this one, for number 5, the first thing we're going to do, again, we're going to factor the top and the bottom. So, using the same method we just did, I'm going to factor. So what can I factor out of the top? What can I divide both of those by? 2. So I have 2. Can I divide by anything else? Nope. So I'm going to have x squared minus 9. Everybody good with that? Sure. I just divided the 2 by 2, divided the 18 by 2. Then on the bottom, what can I factor out?
4.
A 4. On the inside, I will have x plus 3, correct? Now, there's another, is that top part, is that as simple as we can get? Is the numerator as simple as we can get it? No, why not? Alright, we can factor it, and this is something that we kind of need to review for a second. This is a special type of factoring. Is the x squared a perfect square?
Yes.
It's a weird way of asking it, but can I take something and multiply it by itself to get x squared? Yeah, what? X. X squared is x times x, so it's a perfect square. Is 9 a perfect square? Yeah. The square root, its square root is 3. So this type of factoring is called the difference of squares. All right, it's called that because you have a perfect square minus a perfect square. Now that's a nice way of factoring. So yeah, we're going to factor this part as well by, and I'm going to write this down here so we remember that it's the difference of squares. But it's a nice way of factoring. It's really, really easy. I'm going to leave the 2 on the outside. Then, if I factor a difference of squares problem, I'm going to take the square root of the first one. So what's the square root of x squared?
X.
What's the square root of 9? And so what I'm going to do is I'm going to write them just like normal.
Better now than
I'm going to write it just like I normally would. I've got an x and the factor in parentheses, the other x and the factor in the parentheses. But now we've got to worry about the signs. But with the signs, all we do is one's positive, one's negative. Every single time. That never changes. So one's going to be positive, one's going to be negative. It doesn't matter what we're doing, as long as the first term up here is a perfect square, as long as this is a perfect square, I take the square roots of each of them, say x plus 3, x minus 3. Then I've got 4 times x plus 3 on the bottom. That didn't change. I did not change that. Are we good to simplify? Good. We can cancel out the x plus 3, but what do we do before we cancel out the x plus 3? The restrictions. So, my only restriction here is the x plus 3. So I'm going to say my r, x plus 3 cannot equal 0. So what do we do to solve it? Subtract 3. So x cannot equal negative 3. Then you already... Can we simplify anything else? The 2 and the 4. I can divide them both by 2, so the 2 on the top will become a 1. The 4 becomes a 2. So then I've got x minus 3 over 2. Everything else is gone.